Hello everyone, welcome back to Neet and JEE Preparation Physics Test number 3. So just before watching this video, please go to the description and click the link for writing the exam. All the best for everyone. Now let's discuss the question number 1. In the arrangement shown in figure, the coefficient of friction between all contact surfaces is mu. The blocks have masses small m, capital M and m dash as shown. The maximum value of m dash so that the system is in equilibrium. The system is in equilibrium. So first of all, let's draw the free body force diagram for m dash. If you draw the free body force diagram for m dash, so this is the m dash, there will be force will be acting vertically downward, that is equal to m dash g. And one more force you can see here, that is on the string. So we can say here there is a tension will be acting upward. We can mark it as tension T dash. Okay, the tension is the T dash. So this is the free body force diagram for mass m dash. Next one, if you draw the free body force diagram for small m. So consider for small m, what all forces are acting on small m? On small m, there is a force which is acting left hand side, that is the tension T. So look at the diagram here. There will be tension will be acting, say it as T. So here also there will be tension T. Here also there will be tension T. Same way tension T here. Here also tension T. And on capital letter M, the tension will become what? 2T. Okay, this is T and this is T. So here the tension will be acting on M, capital letter M will be 2T. So on first block, that means small m, tension will be acting left hand side, and one more force which is acting right hand side, and that is called the friction. Okay, the friction between small m and the block capital letter M. So here we can say here there is a friction, we can write it as mu mg, right? Mu mg. Here all surfaces in contact having the coefficient of friction which is equal to mu, so we can write here word mu mg. As we already know, friction is equal to what? Mu into normal reaction force. Normal reaction force on small m is equal to mg, right? So mu mg is the friction which is acting on the small m. Now same way, if you consider the bigger mass or the bigger block, if you consider this is the bigger block, what all forces are acting on the bigger block? One, you can see here towards the right hand side T dash will be acting, because the T dash is acting on M dash. Same way T dash will be acting on M also. So towards the right hand side we can say there is a T dash is acting. Now towards the left hand side there is a friction acting between surface and the capital letter M block. That is equal to, what is the equation once again, mu n. Right here we can write here word mu into, what is a normal reaction force? There are two masses are there, right? So we can write here word mu into m plus m into g. The total mass is equal to what? Capital letter M plus small m into g. That is a friction acting towards left. And one more force you can see towards left, that is the 2T. Tension 2 times. So 2T will be acting towards left hand side. Now there is a mu mg acting on m1. So definitely according to Newton's third law there will be equal and opposite force will be acting on m also. So we can write here towards the left hand side one more pseudo force will be acting, that is equal to mu mg. That is equal to mu mg. Now the question is talking about the system is in equilibrium. If the system is in equilibrium, we can write from the first case T dash is equal to m dash g. So this is the first equation. Next case, look at the block M. What is the equation become? T dash is equal to mu into m plus m into g plus 2t plus mu mg. This is the left hand side forces are acting here. And one more equation is the, so this is equation number 2. Now look at the small m. You can see here the T is equal to mu mg. T is equal to mu mg. So we got now 3 equation. Now you substitute this equation. What is T dash in the equation number 2? What is T dash? T dash is equal to m dash g. which must be equal to, you see this one in this equation, mu into capital letter M into G plus mu into small m into G plus 2 into tension. What is the tension? Mu mg, right? So we can write here what? 2 times mu small mg plus mu into small mg. Therefore, we can write here m dash is equal to, you see everywhere g is the, so we can cancel the g. Okay, we can cancel the g from everywhere. So what is the remaining one is coming the mu into m small m, 2 mu m and mu m. So what is the total value here? 1 plus 2 3 plus 1 4. So 4 mu small m plus mu into capital letter M, right? So what is the m dash is equal to, we can write here m dash is equal to, if you take the mu outside, we can write the 4 small m plus capital letter M. So m dash is equal to mu into 4m plus m. So this is the value of m dash. If you are writing in terms of m dash g, the option D is the correct answer. So here the answer is option D. Okay. Now let's do the question number 2. A plank of mass 3m. So this is the plank. This is the mass is 3m. Placed on a rough inclined plane, and a man of mass m. So man mass is given the m. Walks down the plank. If the coefficient of friction between the plank and the inclined plane, so this is given the, here the value is given the mu is equal to 0.5. Here the man is now walking down, right? So the maximum acceleration of the man so that the plank does not slide. So the plank does not slide is, so few options are given there. So now let's draw the free body force diagram for the plank with the man. Okay. So I'm just drawing here, instead of a man, I'm just drawing a block, same mass of a man. So this is the man mass, and the mass of the plank is given the 3m. Now this is placed on an inclined plane. Which all forces are acting on these masses on the plank? So you can see here the force which is acting vertically downward, that is equal to what? 3m plus m, that is equal to 4mg vertically downward. It can be resolved into two components. It can be resolved into two components. Which all components? If the angle is given the 37 degree, so this angle also become 37 degree. So this become 4mg cos 37. That will be equal to the normal reaction force. That is equal to normal reaction force. And towards the left hand side, you can see here 4mg sin 37. And now you can see here, when the man is now climbing down, or when the man is now walking down, he is actually pushing a force behind, right? So definitely there will be a friction in total will be acting in backward, say it as friction F. As we already know, friction is equal to mu into capital letter N, normal reaction force. That is equal to mu into, what is a normal reaction force? That is equal to 4mg cos 37. That is, we can write here 4mg cos 37. Okay. Now the person is now accelerating downward. Okay. Or the person is now walking downward. The minimum acceleration of the man so that the plank does not slide is, that is 4mg sin 37. Okay. 4mg sin 37 minus mu into 4mg cos 37, that is equal to mass of the man into acceleration. Now we have to calculate this acceleration. So just to calculate this value, 4 into, what is the mass? M only, right? So mg sin 37. How to calculate the sin 37? If you draw a triangle like this, if this is the 37, this is the side become 3, this is 4 and this is 5. So sin 37 is equal to what? opposite side divided by hypotenuse, that is equal to 3 divided by 5 minus mu what is the value of mu? 1 by 2, 0.5 into 4 into mg cos 37 4 by 5, right, approximately 4 by 5, which is equal to m into a. Everywhere m cancel, you see m cancel. Now you can see here 3 by 5, or we can say 120 divided by 5, we'll be getting 120 divided by 5 here, because g value is given the 10, minus, you see 4 into 4 16 by 10, 160 divided by 10, 16, right? So answer become what? Minus 16, that is equal to acceleration a. Now what is the final answer? Therefore acceleration a is equal to 120 minus 16 into 5, that is equal to 80 divided by 5, that is equal to 80. 120 minus 80, 40 divided by 5. So answer is equal to 8 meter per second square. So the option you can see there, that is the option A. Alright, now let's do the question number 3. A block of mass M is placed on another block of mass capital M. You can look at the picture here, which itself is lying on a horizontal surface. The coefficient of friction between the two blocks is mu1. So here the friction is given the in between M and capital M is given the mu1, and that between the block of capital M and the two blocks without separation, and that between the block of mass capital M and a horizontal surface, this is a horizontal surface, that is given the mu2. What minimum horizontal force can be applied? You see the force is applying towards the right side. So what should be the minimum force or horizontal force? So what is the maximum horizontal force can be applied to the lower block so that the two blocks move without separation? Without separation means what? They are now moving together. So now let's draw the free body force diagram for small m. Okay, so this is the small m and this is the capital M. Okay, now first of all, what all forces are acting? First case, on capital M there is a force which is acting right hand side. You see a force is acting towards the right hand side. So definitely there will be a friction will be acting in between the surface, right, and in between the surface and the block. So here we can say here the friction, say it as small f. What is the friction in this case? We can write here, is already given the coefficient of friction is mu2. So we can write here f is equal to mu into n or mu2 into n. What is the equation become? Mu2 into n means what? The total mass now. Total mass means what? Capital M plus small m into g. So we can write here mu2 into capital M plus small m into g. So that is the backward force. Now when the force is applied towards the right hand side, you can see here there will be a pseudo force will be acting on small m. So you can see here there will be a force which will be acting on towards back side, that is the m into a pseudo force will be acting. Same way there will be friction will be acting in between the two blocks, that is you can see here once again f or f dash, that is equal to mu1 into normal reaction force. So what is the f dash here? F dash is equal to mu1 into, what is the n here? N means this is a small m, right? So the normal reaction force is small m into g. So these are the forces which acting on these two blocks. Okay. So now what is the condition for non-slipping? The force in upper block must be less than or equal to limiting friction. So what is the condition for non-slipping? Non-slipping condition is here, force in upper block. Look at the upper block here. Force in the upper block must be less than or equal to limiting friction. Less than or equal to limiting friction. What is the limiting friction in the upper block? That is equal to mu mg. It must be less than or equal to mu mg. So let's use that formula here. In this case we can write here MA must be equal to, less than or equal to, so we can write the equal, MA is equal to mu1 into mg, mu1 into mg. So m cancel. So what is the equation for acceleration? Acceleration is equal to mu 1g. Say it as a equation number 1. Equation number 1. Now you just think about these two blocks are now without separation, it is now accelerating. Alright. So what is the reason for the acceleration here? Therefore we can write here on the second block F minus F. Look at the second one. F, it is acting towards the forward direction, right? So F minus F must be equal to, now which block is now accelerating together? Capital letter M and small m, right? So we can write here capital letter M plus small m into A. That means resultant force is equal to mass into acceleration. Here the two bodies are not sliding, they are moving together with an acceleration A. So we can write like this. So what is the equation we can write? F minus, what is now F stand for here? Mu 2 into M plus M into G is equal to M plus M into A. Now we have to calculate what is the maximum horizontal force can be applied. So we have to calculate here the force F. So F is equal to, you see the equation become M plus M into A. What is the A here? A here mu 1g. So we can substitute here mu 1g plus mu 2 into M plus M into G. So in this equation you can see the M plus mg is common. So we can write here F is equal to M plus M into G. It is common now. In bracket you can write the word mu 1 plus mu 2. Mu 1 plus mu 2. So what is the correct equation? Look at the options here. So the option D is the correct answer. So hence the answer is option D. Now let's do the question number 4. In figure m equal to 2m. So this is equal to 2m is given there. If there is no friction between the block of mass m and the ground, there is no friction between the block and the ground. The coefficient of friction between the block is mu. So there is a friction between the two blocks, that is given the mu. The minimum value of mu for which the block move together. The block is moving together means these two blocks will have same acceleration. Okay. Now look at the diagram here. On small m, on the right side, you can see the mg acting vertically downward. So definitely there will be tension acting upward. Same tension will be acting in the same string. So here also the same tension will be there, and here also the same tension will be there. Now let's draw the free body force diagram for small m and capital M here on the blocks. So on small m and on capital M. On capital M, that is equal to 2m, and small m is here given there above. Force acting on 2m, that is the tension T. Okay, only one force is acting, that is a tension T. And there is no friction acting between the surface of contact and the block 2m. But due to this tension, there will be a friction will be acting on small m in this direction. Say it as F. And definitely there will be also a pseudo force also will be acting towards the left hand side. You can write it as m into A. Okay, so these are the forces acting on the small m and capital M, and already we have written this formula. Tension is acting on the string and mg is vertically acting downward. Now in this case mg will be greater than tension, so we can write this equation as in the string, that is mg minus tension is equal to m into A. Say it as equation number 1. Now in the question it is talking about the blocks are moved together. Blocks are moved together mean you see the first block M, we can say here the frictional force must be equal to m into A. M into A. Now what is the frictional force? Frictional force is equal to mu n is equal to mg. So we can write here what mu mg is equal to ma. So m cancel. So we got now another equation, A is equal to mu g. Say it as equation number 2. Now look back to the two blocks here. This tension make these two bodies accelerate. Correct. So we can write this equation as tension T is equal to m plus m into A, the acceleration A. Say it as equation number 3. Now look at the equation number 1. Okay, equation number 1. Substitute the value for tension in equation number 1. So what is the equation become here? mg minus tension is equal to ma. That is equation number 1, right? Now we are going to substitute the value. That is equal to mg minus tension. Tension is equal to what? M plus m into A. M means 2m, no? So we can write here what? 3ma is equal to ma. That is mg is equal to 4ma. So what is the value here? M cancel. So g is equal to 4a, or a is equal to g by 4 meter per second square. So this is the acceleration we'll be getting for these two blocks. Okay. So what is the acceleration for these two blocks? A is equal to g by 4 meter per second square. Now what we have to calculate? Mu, right? Just use any one of the equation. We can use the equation number 2. What is equation number 2? A is equal to mu g. Substitute here, mu is equal to a by g. What is the a here? A is equal to g by 4 divided by g. G cancel. That is equal to 1 by 4. So mu is equal to 0.25. So look at the option. Option C is the 0.25. So option C is the correct answer. Now let's do the question number 5. The system is pushed by the force F as shown here. Look at this case here. 3 blocks are the 2m, m and 2m are pushed with the force F. All surfaces are smooth except between B and C. That means this is the case B and C. Friction coefficient between B and C is mu. That means there is a friction between B and C. Minimum value of F to prevent the block B from downward slipping. That means when you are applying a force on these 3 blocks, we can imagine that these 3 blocks now are moving together within a common acceleration. You say it as the common acceleration is equal to force divided by total mass. Total mass means what? 2m plus m plus 2m. That is equal to F divided by 5m. This is the common acceleration. Now B will not slipping down. That is, this small m is not slipping down mean. What is the reason for that? It is due to friction, right? So which all forces are acting on that one? We can say that mg will be acting vertically downward. Mg will be acting vertically downward, and there is a friction is acting opposite direction, right? What is a friction here? Maybe we can say that friction is equal to mu into normal reaction force. Mu into normal reaction force. What is a normal reaction force? So let's draw the 2 blocks once again here. This is the block B, okay? This is the block B, and this is the block C. This is the block C. This is 2m and this is m. Now you look at this picture here. Both are moving with the, all the blocks are moving with the same acceleration. So what is the acceleration for block C? We can see here the acceleration of block C, which is equal to 2ma. 2m into A. That is the force acting on the C now. 2m into common acceleration, right? Now look at this picture here, B. B will be exerting a normal reaction force on block C, and definitely according to Newton's third law, block C will exert the same force backward also, and that will be equal to what? That is equal to 2ma. So what is the normal reaction force is applying here? We can say that the normal reaction force on C by B, which is equal to 2ma. That is equal to 2ma. Now you can use the equation here. What is equation? It should not fall down, right? It should not fall down means what? This mg must be equal to mu n. This mg must be equal to mu n. So substitute this equation here. The downward force mg must be equal to mu into n. N is equal to what? 2m into A. Now you substitute the value. Mg is equal to mu into 2m into acceleration. What is acceleration? F divided by 5m. M cancel. Now let's write the equation for 5. Now let's write the equation for F. F is equal to, you can write this one, 5 mg divided by 2 mu. So the option A is the correct answer. Option A is the correct answer. I hope you understood this one. We'll see you in the next Sunday. Thank you.